To help us to dive deep into this, I'm now joined by Ziyadin Cakir, who is a geology professor over at ITU, that happens to be Istanbul Technical University. Good to have you on the show. There is a lot to discuss because a lot of us really don't understand how earthquakes really work and the potential and the real sort of potential for damage that they can cause. We generally try to concentrate on them when a natural disaster happens. Let's actually bring up our first map, then we can start discussing this. All right, here we have a map of southern Turkey, and the magnitude denotes the size of the earthquake. An earthquake that measures 5 on the scale is a powerful one. An earthquake that measures 6 is actually 10 times as strong as that. As a 5. So we're talking in the 7s. This is infinitely or perhaps 100 times stronger than a powerful earthquake, right?
They are huge earthquakes. I mean, but when you look at the map, what is missing here are the fault lines. And putting a figure like this is kind of,
okay, let's overlay. If we can ask our director to actually put up the map of the.
So the earthquakes are not happening on randomly on random places. They happen on faults.
Okay.
Most of them are already mapped in Turkey.
Okay. So if we can put up that map that shows the seismic zones of Turkey, we can get a better understanding of where the fault lines run through the country.
Or the next image that I put.
Or we can put up the next image.
Yeah.
Okay. Well. Okay. So this is the fault line. So obviously, if you're seeing a color of red, that's going to imply that there's some sort of a dangerous zone.
Danger, yes.
There's a fault line, and you can see from the map of Turkey, there are multiple fault lines. And the ones that we're talking about right now is the southeastern Anatolian fault line.
This one. This is quite famous one. It's called East Anatolian Fault, which meets with the North Anatolian Fault here at this triple junction, Karlova here. So during the 19th century, there were a lot of earthquakes on this part. The eastern section was already broken. And what was quiet was this part. Since 16th century.
Okay, so there actually hasn't been any significant seismic activity on the lower end of the
western, southwestern end of this fault was quiet since almost like 500 years since the last earthquake was in 1513.
So geologists and seismologists had a very good idea that there was a lot of built-up pressure in this area.
Yes.
And they were expecting
earthquake of this size, yes.
This size as well, something above 7.0?
7.7, of course, yes.
Okay.
7.7 was given by some scientists, some less, like 7.6, etc. By simply measuring the length of the unbroken section, you can have a rough estimate of the size of the future earthquakes. We knew that this would happen, but what we didn't know was timing.
Okay. And that seems to be one of the critical issues when it comes to the prediction of earthquakes.
Yes.
Scientists know if it's going to happen, but they don't know when it's going to happen. And that's the big question. Is there any part on this particular fault line that hasn't broken, that poses risks in the future?
Yes, maybe we can talk about this in other pictures. I'm going to show some maps.
Okay, let's actually bring up our next slide if we can.
Okay. This is the map of aftershocks distribution within the first 4 hours. Okay, it was 10 p.m. a.m. in the morning. I plotted this map so that the yellow circles indicate the aftershocks.
Okay.
So you can.
So the two red stars indicate
the main shocks.
Okay.
The first one here, it's not exactly on the East Anatolian Fault, but it's some 20 kilometers south of it. In fact, it started here, ruptured northward, and triggered an earthquake, the rupture on the East Anatolian Fault. Okay, and 9 hours later, then the second shock took place here near Elbistan. So basically, within 4 hours or so, you can tell where the earthquake happened. I mean, the extent of the ruptures. So basically, from here all the way to Antakya, here you see Çelikan, and from here you see Malatya towards Elbistan, and here.
That red line up there denotes a previous earthquake that dates back 2-3 years.
Yes, 3 years ago, it's Elazığ earthquake 2022, magnitude 6.9. So basically, this one, the first one, is the continuation of this rupture. There was like a 3 years of delay. So especially after this earthquake here, all the attention was drawn on this area, in fact. I mean, we were talking about this on different platforms, you know, in scientific platforms and, you know, and social media, etc. But of course, we didn't know that.
So where does this, after these two powerful earthquakes, up until where did the fault line break? Where does the break end right now?
Okay, the break. Let's move to the next picture, please. Okay, this tells you where the ends exactly, and this is you see this is a map of Earth's surface displacement, which is imaged by satellite imagery. So of course there are some calculations. Okay, so the red is moving this direction, blue is moving westward.
So we're talking about horizontal displacement.
Yes, these are east-west displacement, the east-west component. Okay.
Okay.
So this, of course, took some time to obtain because the satellites were not didn't fly immediately after the earthquake. It took like 3 days. Usually, you pinpoint the location of the rupture. Okay. The across the color contrast between blue and red, you see.
So
and the second one is here.
The ones in red that actually is on the south of this line that runs diagonally has moved west.
These move
and the ones
right.
And the area that's
east.
north to that black line is actually moved to the left or to the west.
Yes. So you
or to
have
the east, sorry.
a motion of like this. Of course, this is east-west component. Normally, the motion is like this.
Okay.
Okay. So the rupture ended here near Kırıkan and all the way to Çelikan here. And this one, in fact, is this is not drawn here, but this is the end of this edge of this blue patch here goes up to here. This is nearly Malatya.
Is that that's the one that actually is the second earthquake that happened 9 hours after?
That's right. This line here, the black line, is the surface rupture. It goes up to here, from Malatya to here. Elbistan is somewhere here, Elbistan here, and to this point.
Okay, but
so this is 300 kilometers, by the way.
Okay, and this
is 150 kilometers.
So the 300 kilometer section that you're just showing, that's part of the main southern Anatolian fault line.
That's right.
The one up on a little bit north, near Elbistan in Kahramanmaraş, is that a tributary? Is that a smaller fault line?
It's a secondary fault which splays off from the East Anatolian fault somewhere here. But this section did not break because that was broken in 1986 already.
Okay.
So this was broken, so there was nothing to release, and the rupture, the earthquake rupture, diverted northward towards Malatya.
Are there other smaller faults that actually branch off from this main fault line that remain unbroken at this time?
Yeah, there are some. For example, if you follow here, there's the fault line that connects to the Dead Sea Fault towards Syria. And there are some other here. There's a Malatya fault I'm going to show later in other pictures. Yes,
okay.
There are some.
If we can move on to our next slide, we'll actually maybe talk about that as well.
Okay, here the displacement in east-west direction. But here what you see, the horizontal displacements. Look at the arrows, direction of arrows. All this side is called Arabian plate.
And that's the larger tectonic plate that's actually pushing up against
pushing northward.
Eurasian plate.
Yeah, Eurasian plate and Eurasian plate, Anatolian plate, that small plate, escapes from this collision zone to the west.
So obviously, colors that are have an orange or a red tone, there is more
Of course, you see,
horizontal displacement.
from 0 to, you see, from orange to red, the amount of displacement, the amplitude increases.
So some areas have actually moved close to 5 meters.
In fact, more. This is the scale kind of saturated, but here you see up to 8 meters. This is the second earthquake here, like 150 kilometers. This one here, like 8 meters.
Professor Ziyadin Cakir, thank you very much for joining us. I mean, I think because of the work that you're doing when it comes to mapping and modeling plays a critical role in how we understand natural disasters like this. Thank you very much for coming onto our continuing coverage.